I'm super impressed how you can count down to 5 JM. Not everybody can do this.
Is that the newest process mining skill set? It's not data science. It's counting to 5.
Backwards. It's the
backwards. Okay.
Advanced version. Yes.
Wow. Are we reverse engineering process? Whoa.
Do we threaten some copyright infringements here?
That's What's Your Baseline.
Welcome to the What's Your Baseline podcast. In this show, we talk about our experiences and lessons learned in enterprise architecture and business process management. What's Your Baseline is designed to be for everyone. Newbies who are just getting started with these topics, organizations who want to improve their EA and BPM groups and the value they get from it, as well as practitioners who want to get a different perspective and care about the discipline.
Each episode will tackle different key topics, providing context, background, best practices, and stories from the road, inviting you to learn from our challenges and successes, and demonstrating key tools to help you set up your practice and get the most out of it.
I'm your host, Roland Wolt, and I'm joined today by my co-host, JM Erlinson.
Hey, JM, how are you doing today?
I'm doing pretty good, Roland. Once again, our audiences don't know when we record these, but we're recording this on a Friday, and you know what that means. Plenty of time to work over the weekend. I'm just kidding. I'm going to take a little time off, and by that I mean I'm going to do only a small amount of work. How about you, my friend? Are you actually going to get some time to rest?
Typically the weekend is obviously the two shortest day of the week, right? And this weekend will be even shorter because I will fly to Portland on Sunday. So I will spend a significant amount of time in an airplane, actually two. So if you need something from the Denver airport, like t-shirts and stuff, happy to buy those for you because my flight back is also with a one stop in Denver. So just let me know.
I want a t-shirt that says, I went to Denver and all I got was a stupid t-shirt. That sounds like a good thing I would like to wear on stream. So everyone, if you're going to see a What's Your Baseline short in the future, you can tell whether or not Roland bought me and sent me a t-shirt that says, I went to Denver and all I got was a stupid t-shirt.
I will have a look out for it. Yes.
Well, what are we talking about today? I know this is a little bit of a fun introduction from us, but I know we have a really great topic today. And let's get started, Roland. You've brought a good friend to the show. Tell me a little bit what we're going to expect today from our new friend.
Well, so first of all, yes, we do have a guest today, Sebastian Kotulla.
Yeah.
He joins us from cold and dark Germany, I guess, at the end of January. And we do something like a sequel of the Lean and Six Sigma episode that we did just before Christmas. So today's topic is lean and process mining, because I think this is a big gap.
So welcome, Sebastian. All right.
Hey. Hi, guys.
I feel like you're a little taken aback by the banter with which we choose to engage as part of this fun little podcast. We had a nice little interview beforehand. It was kind of low key and chill. And then, of course, Roland and I just turn on when the lights come up. So it's ready to rock, my friend. And welcome to our little show here. And also to all of our audience, welcome to meeting a new friend, Sebastian.
Hey, Sebastian, who are you? Talk a little bit about yourself. Why do we have you on the show?
Right. As you mentioned, Lean Six Sigma will be the topic in combination with process mining. And I find this amazingly interesting as I'm Lean Six Sigma black belt. And I'm kind of a hobby nerd. So I love technology, and process mining is one of the very, very interesting topics I'm into. Bit of history maybe. So I have a very practical background. So I did an apprenticeship in electronics back in the days in Germany. Then basically I started to work. Real work, And then
what do you do today?
Talking.
So the fake work came after. I see.
No, really. But I mean, that was quite interesting because I was in the wind business quite early. So we were building and installing measurement systems to measure prototypes of wind turbines, basically, right? All kind of stuff, mechanical loads, power curves, and all that. We were assembling the measurement systems, and then we were installing this across the globe, basically.
I always wanted to ask, when you measure that, do you have to climb up on the wind turbine, or
Yes.
is there a little plug on the bottom of the tower that you just plug in your laptop and you get the measurements from there?
No, typically, if you do a certification for a wind turbine, you need to you cannot just plug into the measurement system of the turbine. Otherwise, it could be some tricks in there, right? So you will do your own measurement system installation with all the sensors included. So we are climbing up the turbine, or were climbing up the turbine into the blades, installing strain gauges in the blades, acceleration sensors within the turbine, all kinds of different sensor stuff, and then field bus systems up to a measurement system. And usually there was a met mast somewhere nearby where we needed to have some reference measurements. So for the wind speed and so on. Yeah.
Mm-hmm. Wow, that's really cool. So it's not that often we have like a straight up engineer on the podcast, and also someone with very practical experience. I'm assuming you also climb. Do you have any sort of climbing certifications or experience coming after that, or is it just all for the work time?
No, not as a hobby, but
too real.
But of course, we were climbing quite a lot, and you need some certificates working at heights. And if you go offshore, you need sea survival training, helicopter underwater escape training, and all those funny things. So that's pretty interesting. So this is an adventurous job, right?
Wow. And does that mean you're an adventurous person? So tell me a little bit more about not just your work history, but what do you do as a hobby? If you've had work history that's already pretty extreme, what makes you happy on your off time?
Wakeboarding, for example.
Okay,
I like
that
wakeboarding. I like, typically I like fighting, but I didn't do this for quite some time. So I did Wing Chun and kickboxing for several years, but that's already in the past. But I like it quite a lot, so I still do a lot of training at home, but I don't fight that much anymore. Yeah, and soccer, of course, right? I mean, I'm a German, so of course I'm playing soccer a lot. Yeah.
But hey, we didn't invite you to the show to get our behinds kicked by you. But obviously having a conversation about the experience that you bring to process mining, and what we didn't ask because I was so curious is, what do you do today? You know, I obviously I see you standing in your office, so you're not on a wind turbine anymore. But what have you done since then?
I took over a department pretty much after a couple of years, so pretty soon. I took over the technical department where all the guys were preparing the measurement systems and doing the installation. So I was heading up a team in Germany, in Pamplona, in Spain, and in Brazil. So that was quite interesting. Back in the days, remote management, that was interesting. And afterwards, I got a job in wind turbine erection and was the managing director of a company there for 2.5 years approximately, with 300 employees. Mainly the work was done in Germany. So we were installing wind turbines everywhere basically. And since a couple of years, I'm in management consulting, focused on lean, but on the digital part of it. I'm much more interested in the digital part of it. Of course, all the lean basics is nice, and this is the fundamentals really to make things happen. But I love the digital technology. So right after my apprenticeship, I did which is I don't know if this is available somehow in the US, but that's a Meister, so a bachelor professional, you could say, in automation and IT. And afterwards, I did a normal bachelor, and then afterwards, I did my master in economics and engineering. And that was quite interesting because within the last one, I was my master thesis actually on process mining and on wind turbine maintenance processes. So that was pretty interesting because it's not that easy to get all the data points and to map all the data points in the right way so that you have a good model that you can understand afterwards. Because of course you have SAP data where you have a lot of, or ERP data, right? Whatever you like. there you have a lot of data points, but within the maintenance process, for example, you have a lot of different steps, which is not captured in any type of system. So you need to find a way around that, right?
Yeah, so things came to a close for you, but maybe we just dive into the topics of today. So talk to me a little bit about how do you bring in process improvement and process mining into the bigger picture that you see in your daily work?
Sure. What I really like about process mining is the fact that it's this proactive approach, right? So typically in Lean, if you just follow the Six Sigma process, which is a DIMAC, right, which start with a define. So then you need to define a problem, which means you need to have a problem. So it's already something happened, right? And with process mining, you have the opportunity to be proactive and really see, okay, where do I see indicators for potential problems? What can I really improve, right? And this end to end, if you did your data model in a good way, this is extremely powerful to always take a look on what's really going on and where do I need to put my energy, money, efforts, resources in order to improve processes, right? So this is why I like it.
Right.
Yeah, I agree. What you don't see enough is when you read process mining literature or follow podcasts or whatever, you always see, oh yeah, we're going to do this. And then we do the data model and then we do the dashboards and whatever, right? And once you configure the tool, a lot of people think they're done. You know, in my opinion, this is where the work just starts. And I think I see a gap out there where traditional process analysis methods like Lean and like Six Sigma can add a ton of value to this. But if I remember it correctly from my days when I did a Lean training, obviously the process is typically in the middle of it and you're looking for things like waste, as Ron explained. So how do you approach a process mining analysis when you just get started? You know, you got called in, you got the data set, you got the process. So where do you start looking for things?
Yeah. So actually it's before the actual analysis, I usually use the CRISP framework from data mining, where you start with business understanding, which is a crucial topic in here, and then data understanding, and then data cleanup and preparation, and then you choose the right process mining algorithm for your particular use case. And but then if you did this, of course, then it's really about finding the big issues, the bottlenecks, for example. So every time you have high frequency and low efficiency, this is something where you could take a deeper look into what's really happening. And what is really nice, if you have a good data set, let's say, where you have resources and everything attached to it, you can already describe the problem a bit better. In Lean, we typically use so the problem definition is one of the very important parts, right? A good and well-defined problem is half solved, we say. So that means we have this structure of 5 W's and 1 H, which basically is what happened, why did it happen, where, when, who was involved, and how did it happen, right? So if you describe all this in a very good way, you have more indicators on who to ask maybe and what to spot. Was it in the early shift? Was it in the afternoon? Was it in the weekend or whatever? So you can describe and frame the problem in a very good way, and process mining helps you doing that.
Yeah, that makes a lot of sense. And I like how you're talking about these things. These are frameworks that you're bringing into the context of process mining from other disciplines. And I think that, we see a lot of people these days talk about this cross-domain knowledge, this cross-methodology approach, because everyone's pillar that they really specialized in has great things to offer, but put them together and now you're overcoming some of the shortcomings. Something you said earlier that I really love as well is this idea that you want to help understand and define the problem using data as your guide, rather than trying to address a problem you've identified with a methodology. So you're starting from the question, not from the answer of what's my problem. And I think that's a really, how do you sell this early on to an executive stakeholder to say, like, listen, we're not going to come here and solve your problems. We're going to come here and find your problems. Like, what's the pitch here? Because you're starting sort of green field, right?
Right. Yeah. Of course, you could go both directions, right? So if there is any particular problem, then it might be the question if process mining is the right tool for this or not. But it could be, right? But really, this more proactive approach, right? Telling people, okay, let's focus on it's always a bit this leading and letting stuff, right? So what is really indicating that you're on the wrong path? Because at the moment, things are happening so fast in every industry that it's more attractive for people not just to focus on something when something bad happened, but when really you have the proactive focus. Basically, you see things before they really make problems.
Yeah, that makes sense. But now you've identified, okay, you got the problem, you see the process. What would be questions that you would ask when you look at a process, right, from the lean perspective?
Yeah, I mean, usually, of course, timing is a crucial thing, right? So to identify, okay, where do I have potential bottlenecks? Because it's all about flow in lean. So we would like to have a steady flow with it, so that it's always or sometimes a bit misunderstood, but it should be a steady pace so that you don't have a lot of unbalanced work, let's say. So, and then of course we focus on the different waste types. So what can we see in the process? And within the process model, it's not always possible to see everything. So we have this Tim Woods acronym, which basically stands for the 7 or 8 waste types in lean. So this is transportation, this is inventory, this is motion, this is waiting time, this is overproduction, overprocessing, this is defects and skills. So all of that is waste. So waste of skills. So you have over talented people, for example. Not everything is visible within a process model if you don't really have it in your data set, right? For example, transportation, if I don't have the locations in between, I just have the timing. I can see this is an indication. So it took a long time. Maybe there is something, but I don't know. And this is always, or in most cases, the fact that I see something within the process mining tool, like long duration, long waiting time, or a short overall cycle time. And then I could, define it better. And then I would say, okay, let's go for a deeper analysis. And then, of course, we have quite a significant number of tools in lean management to do this. Yeah.
And so when you're talking about getting that detailed analysis, so when you're looking at process mining as a data source, what special considerations are you giving to this as a problem definition tool? And how do you use process mining as a feeder for the rest of your project planning when it comes to sort of a lean focused methodology, lean focused project planning exercise? Yeah.
That's it. We talk about the baseline here, right? Which is so.
What is it?
Yeah, what is it?
So in lean, we have this one methodology which is called kata, and which basically is what every consultant would basically say to you. So which is what is the direction you would like to go, and then where are you now, and then set up the next target condition and make experiments toward that. And that's basically the second step of setting the current condition is always tricky in processes, and process mining is based on data, so based on facts. Usually, or the method before was we gather in a workshop, we get a lot of people, relevant people together in a workshop. We draw something on a whiteboard or some brown paper, and then we try to identify pain points within the process. The problem with that is just that this is based on a lot of assumptions, because you have a lot of people coming in and everyone is, could be like this, could be like this. Was it really in the morning or was it in the afternoon or whatever? So it's based on a lot of assumptions. And process mining really gives you the fact-based current state. And this is, of course, this is the reference point for the control phase afterwards. So when we did an improvement, we are able to measure if we did something successful there.
Right. I want to talk about another piece of this puzzle here is project prioritization. Because I'm assuming when you start these conversations, you're defining problems, but how much does process mining inform the relative value of a project? So do you use this in your business value calculations? Do you use this in your project justification? Like, how do you set this up so that process mining becomes a real value creator for you as the consultant?
Yeah. So it helps to make up a case, right? It helps to make up a business case and then to prioritize based on effort and benefit. Basically, this is one thing, and the especially in process mining, the theory behind which I use the most is theory of constraints, which basically just is this bottleneck theory, right? So it should flow, and if you have 3 machines and one is a bit slower and everyone is running on full load, you will pile up inventory, for example. That would be one type of waste. And this is all about this balance within and this flow. And then of course, if you apply the theory of constraints, you can, with process mining, identify the bottleneck, and you can see what that means if this bottleneck would be working in a different way. So you can make assumptions on what effect would that have on the rest, so up and downstream as well, if you know where I'm going.
I do.
Yeah.
Yeah.
The other question I have here is, you mentioned theory of constraints, and I love to talk about this, and hopefully we can include maybe a link to the theory of constraints in our show notes. Quick pitch for the show notes in whatsyourbaseline.com, second conversation. But this one, I want to focus on, how does the theory of constraints work hand in hand, or is it part of the overall picture of root cause mining? So how do you, or root cause analysis, how do you get to there to determine what the levers are that you can push on that would make a meaningful difference to the KPIs you're measuring?
So,
yeah, I know it's a big question. I mean, that's also the secret sauce of your gig, right? Like, you're trying to get to those, here are your levers, here are the things you need to push on, how much you need to push on them, and here's the value you're going to get from it.
Yeah. But the point is that most of the information is not part of the process model. So what you see, what you see is where's the bottleneck, and that's pretty easy, right? So you can see over frequency and durations. It's pretty easy to see where you have your problem in terms of the bottleneck. But then the input factors or the factors as such, right, are not visible in there. In process modeling in general, this is always one of the things. If I go from a CI perspective and say, okay, we have a model here and this is just a control flow. So what should I improve, right? I need the system. I need to understand the whole flow of, okay, this is now done in this system, and this system, and so on and so forth. Resources, organizational changes. Otherwise, I can't see it if it's not in the model, right?
I agree. And that is actually, and I'd just like to repeat it, I think that invisible thing that you just mentioned, right? That is what's missing in quote unquote traditional process mining analyses, right? You need to ask people, you need to get out there, you need to look at the process in real time, all those lean ideas of standing in the shoes and whatever Japanese terms are out for there. I think that all needs to be done to get the complete picture. And in our second segment that we will talk about in a few minutes, we will talk about the how. How do you get there, and what will you do to approach these projects? But before we get to this, Sebastian, the one question that I obviously have is, well, now you've found something, right? You found it either in the process mining process, or you found it in your conversations and all these things. And typically you have a big pile of things that you could do. How do you prioritize what you should do?
Risk, effort and benefit is one thing. So so-called low-hanging fruits, right? But what I don't like on that is usually if I go in somewhere, I see 1,000 low-hanging fruits, and then the next question is what to prioritize there. And it's about, again, what type of data do you have available, or what can you make available in order to really see if this is a relevant topic or not, right? So you need to understand the business always. It's not just about, okay, I see something in the tool. You need to have the business understanding. Typically, I approach the persons working in the processes and have a discussion with them. Is that relevant? Is that really a problem? Why is it a problem? So this problem definition again, right? And if you just go in the first phase of the DIMEC, so this definition phase, and then you say, okay, why is it a problem? How much is it? And if you have this clear picture and you just compare a set of different problem definitions, you can just see, okay, I will scrap this idea and this idea. This is not relevant, and just a small tiny problems. Maybe we can just put that on the backlog and work on that later on.
Yeah, that makes sense. I think this is, I love that quote. I see 1,000 low-hanging fruits. We need to figure out which ones actually matter, which ones we can actually get done. And I think that's really good. And I've really enjoyed this first segment of our conversation. I want to leave people just a bit of a break to unload your mind from this great information and leave you a call to action to think about something during our little musical interlude. So first and foremost, what are your experiences with process mining and process mining analysis? We're talking a lot about that today. What are your experiences with Lean and Six Sigma? And when you look at analysis of the information coming back from process mining, do you stop at the dashboard and just sort of visualize it? Or what other analyses have you done? What experiences have you had? What other steps have you taken to get to the point of improvement suggestion? We'll leave you for a moment and come back with our second section with our wonderful guest, Sebastian.
So welcome back to the second segment of this show. And after we spoke a little bit about the why and how you select the process and define the problem and how you come to suggestions and the prioritization, obviously now is the time to talk about the how. You know, how do I do this? What are the different analysis types or categories that you want to apply to your process mining analysis? You know, how do you get started with this? And Sebastian, maybe I just ask you the first question. You know, you're in a new project, the client gives you a data set, you get a rough understanding of the process, you plug in your data model, you see something in your process mining tool. What now? What do you do next?
Right. Problem definition. It's always the starting point. So really, as mentioned in the first part, really describing everything so that I have all the indicators on who to ask, where to go, what could be interesting additionally. So that's one thing, of course. And then it really depends a bit on the things we see in the process mining tool, right? So one of the most interesting measures in lean management, I would say, if you do a value stream map or value stream analysis, right? So you have this one ratio at the timing area. So a value stream map is divided into this information flow, and then you have your process steps, and then you have your timeline. And there you have this ratio between the overall lead time and the cycle time, which is so interesting. Because this tells you how much, I mean, the product will be in your factory, for example, for 4 weeks, yeah, but the cycle time actually is just 2 hours. So it's just worked on 2 hours. So just imagine to be a part in a production batch, your life would be bloody boring, right? So you would just lay around and wait until something will happen, yeah. Yeah, but depending on that, it will be then what you mentioned before, this foot on the ground, which is called the Gemba walk in lean terms, which means there where the work happens, the place where the work happens. So typically, if we defined this, depending on the data we have, we could either go with a fishbone diagram first, to make some first hypothesis and to cluster it a bit. So it's kind of a fishbone diagram is kind of a manual cluster analysis, right? So you have the head of the fish is the problem definition, and then you have some of those bones, and you have your cluster, so material, management, method, or whatever. And then you find out, okay, what symptoms did I have at which bone? And the basic idea is, like in the cluster analysis, okay, I find one of the bones where I have most of the symptoms. If I solve something there, most of the problems will be away.
Mm-hmm.
Yeah, it's a cause and effect diagram in other terms, right? And what I wholeheartedly agree. I've never seen that, to be quite honest, because
All right.
Obviously the process mining vendors don't give you that as a default thing. Hint, 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 dear process mining vendors, right? But I think if you just take a piece of paper, right, and collect it, because it forces you to think about, okay, what do I actually see, right? And is it relevant? Is that spike that I see in a line chart relevant or not? And if it is, then obviously you got the why questions. Why is that? What's the reason for this? And then you drill down until you get to a point where you say, "Oh, I think I found the root cause of it."
Mm-hmm. Yeah, I think it's interesting here because I see a lot of root cause analysis. And once again, we're advising our process mining vendor friends here. I see a lot of root cause analysis that doesn't include clustering. So it essentially provides a whole bunch of random things that may contribute. When you're talking about clustering, you're trying to understand what the story is. Like, what's the overall issue with the way in which your business operates? And it's not condition A and condition Q. It's this bone has a series of problems. When you put them together, that's the story of why things are breaking down, or at least that's one of the largest contributors. If you could solve this, but solving A and solving Q randomly feels, because there's a bunch of other things that are less important, or maybe it's one little thing over here, that's not going to actually lead to meaningful change. That's like, instead of fighting the fire in the house, you're stomping out each little patch on the lawn. That's not going to actually solve the problem.
And without excluding our guest, because that's obviously a guest show, but I agree with you, JM. It should be clustered, right? I would want to know, what's the organizational thing? Is there a business unit that doesn't work? Or is that a vendor problem? And which vendor? Or is it a regional problem? Or whatever the dimensions you look at, right? And I haven't seen that in a process mining tool. And dear listeners, if you know one that does it, please let me know. But I haven't seen one that does the root cause analysis in that way. Like JM said, they just throw semi-random stuff at you. And that's obviously not really helpful.
And that's in the beginning, it's mostly talking about symptoms, right? What you just mentioned, the drill down into the root cause analysis. This will be the third step in this process, basically. So we would start to cluster the symptoms, right? And the idea is, okay, approximately, if you have 10 symptoms and you have one root cause, you can get rid of all the 10 things. So that's approximately the ratio there. But then the next step is to build your hypothesis from that. So you have this cluster, you have an idea, okay, that could be a management issue or it could be a material issue. And then you do the Gemba walk and really go to the shop floor or wherever that is and figure out if this is really the case or not. Asking operators, having discussions there, observing the process and just checking if this could be the issue or not. And then the third step, if you identified that, okay, this hypothesis is valid and the other one is not, then you would go with the 5 whys, which is basically the method of asking
a lot of stupid questions.
A lot of whys. It's not about why. It's about drilling down to the level where it's a systemic problem. So if your problem is a human being, you did it wrong. You need to find the systemic problem. So is there a process not ready in place, or is that training process not ready, or whatever? So something like this. It's not about finger pointing in lean management or the overall improvement world, right? It's really about finding how can we do this better the next time. have sustainable solutions in place.
I love that. And I think that's something that we can try and assuage some of the fears of people who are having lean management done to their organization. It isn't about finger pointing. It's not about individual actors. It's about systemic problems within the organization. And when you bring in the type of analysis you're talking about, who benefits from that? I mean, it's everybody, right?
Yes.
It's the organization performs better, but you also do your job with fewer frustrations because maybe you're not doing your job at the highest level of performance, not because you don't want to, or you don't mean to, you're not trying, but because you have roadblocks that are placed in your way through bad process, through bad system, through bad organizational design, in general, through any component of the process. Everybody wants this. And by participating together, everybody gets it. That seems really cool. That's a great value statement.
Yeah, that's really the basis. Yeah, so it's a bit of similar to the system theory. I'm a big fan of the system theory in general from Luhmann, because he was basically saying, he was taking out the humans, right? So and he's telling us that, okay, all culture develops from the systems and the rules which are in place, right? Just consider we are playing Monopoly, for example, and our behavior would be according to the rules. We would all behave like a capitalist, and we will fight each other to win, right? So it's not necessarily that I'm a bad person in that, but within the rules of the game, I will play the according to what is the
rules of the game? Yes.
Yeah. Right.
Yeah.
So easy.
Yeah. I'm just thinking about what you just said, and what process mining tools should do, which they currently can't. You said you take out the human out of the equation. But sometimes you have to factor that you have an underperforming person, right? Or a bunch of underperforming people. And it would be great if you had some form of what if analysis in the tools to say where you easily can check off things, take out this user or take out this org unit and just see how the data goes, and make that easy in a tabular comparison, with and without, or different options and all that stuff. But again, we don't do the job for the process mining product managers here. But we're actually looking for a little bit more information about what would be additional approaches to getting the most out of your analysis. And I know we have a grand total of 4 topics. So we spoke about the first, fish bones. Sebastian, what would be another way to approach this?
Yeah, just one point. You just described the dream of a micromanager, right? So, and especially in Germany, we need to be very cautious that we have a lot of powerful workers' council here in Germany. That situation is a bit different.
Well, actually, if I can interject here, just before we get to the 4 methods, because I really feel strongly about this. I have to believe in people. Yes. I have to believe that there are some very rare cases of malicious intent. Fine. There are some people who are lazy and just simply don't want to work. Fine. But in real, enabled corporation, enabled companies, enabled teams, when people underperform, it's not because they're not trying. It's because they don't have the resources they need, or they don't feel motivated to do the job you're asking them to do. So asking a person to swap out, the new person coming in, unless you're very lucky, they're going to perform the same as the last person because the circumstances around their job haven't changed. You need to change the circumstances, and then anyone doing that job will do a good job.
Yeah, but I was more referring to the GUI in the analysis. I do not pull out the Machiavelli and say, oh, take that one minion out and replace him with another minion. That's not what I'm saying. I'm just saying that this should be an analysis type that I would love to see in tools to make that easy and have different combinations being selected and save the result and see this is the result of option A, option 2, option 3,
Absolutely with you. I mean, what you described is just the core of all the system theory, right? So that it's not about one specific badass, if you will. Okay, but yeah, let's focus on the other things what we could do potentially, right? So one thing is really this. Did we use the Japanese term as well, Ishikawa? So
no, we haven't yet.
That's the fishbone in Japanese, all right. So just to get the full language here. Okay. we have another thing, which is called the FMEA, right? So failure mode and what is it called in English, actually? So I just know the German
failure
word.
mode and effects analysis. Yeah.
Effect analysis, right? Exactly. Which is kind of a, blown up risk analysis, if you will, inflated risk analysis. Basically, it is a risk analysis and you have a specific calculation. So what you do is, you describe the potential errors you could have in the process. You describe the impact which this has, what will happen if this occurs, and then you give some numbers to it. So you have the likelihood. How likely is it that this will happen? Then you have the impact. So this likelihood is from 1 to 10. Then you have the impact from 1 to 10, and then you have is it possible to find before it gets shipped to the customer, right? So are we able to spot that and can correct this, yeah? And then you just multiply this. So the last value is turned around so that if you have, if you can see it easily, it's a 1. And if it's hard to detect, it's a 10, right? And then you multiply those 3 numbers and then you have your risk prioritization number, I guess, yeah? And with that, you can just see, okay, this is a high risk or a low risk or whatever risk. And then the idea is to make mitigation plans and calculate again, basically, right? But really based on, it's kind of a bit of a brainstorming exercise. And what I don't like too much on that is that it's this calculation of the number. So giving the scale on 1 to 10 is a bit intuitive, basically, right? Pretty tough for German engineers.
I think it's subjective, right? People just put the number that they feel, and with a multiplicative calculation, that delta of even 1 might make a huge difference on that RPN, the risk prioritization number at the end, right?
That is true. And at least you're working with a metric system, 1 to 10. It's not, we're not talking about fractions and feet and pounds and all that. No, just kidding. Yeah. But I'm thinking along the lines of the process mining tool again. This is obviously what I've seen, basically either in the tool or outside the tool, most likely in the format of a table, you know, and then you just calculate and do these things. So I'm wondering if this could be built in and how you derive those things being fed by the process mining data. And I don't have an idea, so I just throw it against the wall.
Well, actually, as you're thinking, I have an idea because I've seen it done a little bit like this before, which is through risk simulation. So risk simulation includes preventative controls. Remember that controls can be preventative or reactive. So a control is like something bad happened, let me fix that. And a preventative control is I want to make sure something bad doesn't happen, right? You can, in a simulation, theoretically, you can, with all your assessments, with all this information, have the preventative and reactive controls, plus the amount of accumulated damages, plus probability, do a simulation on processes. And theoretically, that could kick out a number of where your riskiest steps are,
and then like a heat map, you like a 4x4,
something like that.
Visualization, maybe.
Hey, product managers out there, we're doing your jobs for you here. Come on, come join us in this little fun time.
Yeah, but it's really a powerful approach because you have a very systematic way of approaching this. And typically you don't do this alone. So the risk that you have just some random number is not that high because you would have a good discussion. Okay, is it realistic that we give a 10 for this specific impact, or is that maybe just a 5? So you would have a good discussion if you do this in a workshop format and not on your own on your desk, right?
And I think you do that after you do the whole fishbone activity, right? Because obviously those things, the outcomes that you identified in the fishbone activity would be then the input for the FMEA analysis.
Yeah, you can combine all those tricks, if you will, quite nicely, actually. Yes. And it makes sense because then you have a bit of, it's always good to have a bit of an idea if you feed a tool like this FMEA and you're just randomly brainstorming, that's kind of tough. So what kind of idea should I have around which topic? And if you start with those clusters already, you can have an idea of, okay, what actually could happen in terms of people? What actually could happen in terms of material? So you kickstart your brain a bit in the right direction.
Right. Yeah. And so we've gone through fishbone and
Yes.
FMEA, the failure mode and effects analysis.
Yes.
I heard there were 2 more on your list. Let's rock them. What else you got there for different types of analyses, different types of decision making support?
Yes. So one thing which is actually one of my favorites, but I don't use that often because it's a bit more for technical things. Really, if you don't have a very mature process, which is the design of experiments. And I mean, this is a hot topic anyways, because this is a statistical analysis on, or basically a statistical method on how to approach a good experiment, how to design a good experiment, and then how to make predictions out of it, right? So typically, it's for complicated problems. So if you would like to test something where you have several inputs and you have, I don't know, a couple of outputs, 1 output, 2 outputs, whatever, and you would like to see the effects from the input towards the output, basically, and then this is just a kind of a factor analysis. This is a pretty standard statistical approach, but it's cool to set up experiments. And when I say set up experiments, of course, you could test all possible all possible variations, but just consider you have 3 variables as input. Right. And then you have 1 output, and then you have different options on your input. So you can have, let's make it easy. You can have 0, or you can have 1, or you can have 0.2 or 0.5. So, and if you would like to test all the different combinations of all the 3 variables and then measure the output, this is kind of a long experiment, right? So this will take you forever. So this is why this design of experiment comes in, and it has the opportunity to make some factored analysis, so where you just take several steps, typically 2 or 3 steps per variable, and then you don't test everything, but you just test a portion of it, basically, right? And then the tool runs, makes it statistical magic, and then you have your model to make predictions. So then you can say, we typically use that when we do lean trainings on this catapult. So you have this catapult. So I don't know if this is the right word, actually. So catapult, yeah. So you throw your. Yes. Okay, good. And so you have different factors. So you have the material of the rubber band, for example, which is pulling this the thing back. Then you have how far do you pull it back, and then you have to which angle will it come back, and so on. So you have different factors, and then you say, okay, I will test on this point and on this point and on this point. Then you do your analysis, as I just mentioned, and then afterwards you can say, okay, if I change the variables from here to there, I can calculate the result. So we can then calculate how far the ball will be flying, basically, right? This is the whole idea, so that you understand your inputs variables much better than before, so that you can then make predictions of when you change something in the input, what will be the output.
Yeah, that's like Monte Carlo style simulation, which is, I think, a tool that a lot of people use for testing input variables on systems, and that's really so. Here's a question for you: how do you use this to make sort of intermediate predictions? So are you drawing a curve out and then finding ideal spaces that perhaps you didn't test in between the points you did to try and come to an optimal solution?
Yeah, well, it depends on the factors you set, right, and the realm of possible solutions. So if you have 3 input variables, you have a 3D realm of possible solutions. So for all economics students, it's most likely easier to draw in 2 dimensions only, because they only have those four boxes, right? So then you can basically the model will create this curve within this realm of possible solutions, and then you can, if you twist your input variables, you can predict on the curve where it will land, basically. Yeah.
Ah, cool. Well, that's great for our option number 3 to try and get some good decisions. And now let's round it out with option number 4. So what do I do if I want to know even more?
Yeah, that's I mean the very cool topic, and then we drive into the operational research topic, basically, right? Which I love. I mean, that's so interesting. What kind of, so you use algorithms on data to find those things what we just discussed, right? To find the right criteria for input variables and so on and so forth. And advanced analytics is kind of a very broad term for that, because that's all and nothing. But if you go to operational research at this topic, you have all this mathematical optimization algorithms like linear programming, or heuristic algorithms as well, like the genetic algorithm or the AND algorithm. So very cool stuff where you can measure and basically kind of simulate, calculate specific solutions for specific problems. So if you have a facility and you have 3 or 4 factories, and you have some ingredients in one factory and some in the other, so what would be the optimal to combine things and bring it from here to there? So in terms of different factors like transportation costs and so on and so forth, it's not just this one factor thing. It's really considering the other conditions as well.
Yeah, and I think we're way outside of any process mining tool at this point in
yes.
time.
But process mining is, I mean, this is the bridge between data mining and, on the other side, business process management. So this is where it really makes sense to go this step further to find the right solution, right?
I think it's a good first start. But while you were explaining those 4 different methods, there was one thought that came to my mind, and that was like, ooh, how long does that take? So Sebastian, do you have any, obviously we don't want to know who the client was, but do you have an example for us where you've done these type of analysis, and can you share some of the experiences? And to answer my question, how long did that all take?
Yeah. Especially the change in the output is always the tricky thing, right? So, I mean, calculating return of investment, and I would like to see something very fast, is always the question in the very beginning. So when is amortization? What is about the amortization time, right? So typically, or one specific maintenance process we measured was basically in the process mining tool, we identified that there is a huge bottleneck or huge time spent on the planning process, right? So you need in maintenance processes, you need to react fast to make your production line work again, right? So if you produce something, fast moving goods or anything else, and your machine stops, you will directly lose money. Yeah. Yes, exactly. Especially for the unplanned work, right? So then it's of course about planning and reaction time. And we figured out that we were pretty slow in the initial reaction time. So it was captured quite quickly, but the time until we got out, or the client got out and solved the problem, was basically too long. What we did then was we did a workshop and investigated a bit more on, okay, what is it really, right? So the first option, which is the easiest to use anyways, because you don't need a lot of programming knowledge or skills for that, because Fishbone is the manual data mining, right? Yeah. And so we started with that, and then we on this specific part of the process, we implemented a second measurement process, so to speak. So we gathered in all the different happenings on every day. We gathered in a performance management setup, right? We gathered, okay, what is the root cause for this particular waiting time? So that means over a period of approximately 3 months, we set the system up. We talk every day about this process, and then we are not happy with the first solution here. What you tell us why we are late, so we need to deep dive, apply 5 whys all the time, and then we gather all the different root causes and make a Pareto analysis of this at the very end, so that we know, okay, this is the big thing we need to work on, and that was basically an IT solution at the very end. So with our colleagues, friends from the IT department afterwards, we were able to enhance the process. But until you see this in the data, in the process mining data, this takes a lot of time, because a system change is not just a system change. There's a lot of change management involved. Within the solution, you need to have the people on board. So this, I don't know if this is the same term, but we call this IKEA effect. So that when people build the solution with you together, the likelihood that they apply is much higher, right? And then of course, we need to bring this live, train the people in the new system. Of course, develop the solution first, train the people in the system, make sure that this is in use in the right way, support them, blah, blah, blah. So until then, you see this in the data that was approximately after, I don't know, up to 12 months really, until we really had a good success with that. But this was a major change within the overall time we needed to get things done, repaired.
Wonderful. Well, that makes a lot of sense. And I'm really glad you've sort of gone over the real practical example of how this can work. And hopefully it can work for all of you listening at home. If this is something that you're interested in, you want to find out a little bit more, we're going to close out our show in a couple seconds and let you know how to get in touch with Sebastian. Of course, there's lots of information you're going to find on the website. So we'll let you know in a second. But before then, I want to leave everyone with a question as we go to a quick musical break. To talk about the methods you're currently using to analyze the information you're getting in today. Let's assume you have good data. It's not garbage. What are you doing with it? What is that analysis method telling you? And what data and analysis methods are still needed to dig further into the root causes, cluster, understand how to improve and where to actually act? And so how can you evolve your process analysis with, of course, what we've heard today to uncover what's truly important and how to address your challenges for lasting change? We'll leave you for a moment and come back with our last section and a close to the episode.
So welcome back. And I don't know how you feel about this, but during the whole conversation, I was thinking like, man, I wish I would have seen all that stuff in a true process mining analysis before. This is so much deeper than just configuring dashboards and looking at widgets and struggling with the data model and all these things that have not been covered. But there's obviously a lot of things that come up and additional questions that come up that maybe JM and I are not able to answer. So therefore, Sebastian, we would love to punt those questions to you. So how can people reach you?
Yeah, all right. I guess the best way is on LinkedIn, really. That's the easiest way, or my email. Mm-hmm. So probably we could put that into the show notes.
We definitely will, right? So yes, we're going to put the LinkedIn in there. We're going to put your email in there. But I also heard there's a little secret, and I don't know if I can spill the beans here, because if your dear listeners are interested in learning more from our wonderful guest Sebastian today, a little birdie told me that he's about to start a podcast. Is that true, Sebastian?
That's true. So far, so yeah, I have quite some episodes already. So far, it's in German, unfortunately. I don't know.
I think with the people that roll into tracks to the show, they're turned on by the accent. So I would suspect a few of them speak German.
All right, okay. It's called Common Sense, and it's basically all when you boil down lean management, it's all about don't make any rubbish in your process and use common sense, and all the fancy things around are just basically methods to do exactly this, right? So at the end, it's just that.
Yeah, common sense. Good two exactly. German words, obviously, yes.
Common sense. And we hope that all of you after today's episode have just a little bit more common sense. But this is, of course, a thank you to all of our wonderful listeners for coming along this journey with us and our wonderful guest, Sebastian. Of course, a huge thank you to him for his insights on lean and process mining today. And boy, I feel like I've taken a whole whack of notes that I'm going to take back to my own job. So thank you so much. And if you love this episode, please go to whatsyourbaseline.com to find out more about the things we've talked about. In fact, whatsyourbaseline.com/episode 39 for this specific episode. And if you wouldn't mind doing us a little favor, please tell your friends. We've got lovely people, more than 1,000 of you loving us on LinkedIn, and lots of views, listens. We'd love to involve more listeners, more people to come to the What's Your Baseline family. And of course, don't forget to follow Sebastian and Common Sense as he breaks it down in German for you on how to make this come to life with a little bit of that sense. Well, until next time, friends, I've been J.M. Erlandson.
I'm Sebastian Kotulla.
And my name is Roland Wolt.
And we will see you in the next one.